Assalamu alaikum and welcome back from our ad break. We are busy with cyclic quadrilaterals and circle geometry for grade 11s and 12s. My appeal and my hope and my wish is that today's episode, today and yesterday's episode, with or our previous episode, helped you to demystify geometry, circle geometry. Like we said, circle geometry, very difficult for many of you to be able to identify. We've went through some of the steps, rules. This was the approach. Start with the knowns, moving towards the unknown. Use our theorems as your vehicle. Identify what's given and select your shortest route. Now, when you are taking down your problem, it doesn't need to be in any order. As the answers come to your head, or as you start identifying theorems, make a note of it there on the side. There isn't a rigid structure in which it should be answered. As long as you are giving justification to what you are saying, you will get your full marks, right? Example number 3, we've done example number 1 and 2 in our previous episode. If you guys have just joined us, we're busy here with circle geometry. We're doing example number 3. Okay, this is our last segment for today's show, but it is not the final episode on circle geometry. We will be continuing with this in our next episode. Okay, so find x, y, z. Like I said, let's identify and let's work out a structure on how we're going to attack x, y, z. We've got a circle, we've got a cyclic triangle, meaning all 3 points. We've got a tangent, we've got radii. We've got a host of information here, guys. So basically, the more information we have, the easier it's going to be for us to identify the unknowns. So let's start filling in information onto our diagram in order to assist us to get to our solution. Let's start with the knowns. Our known is 62 degrees. Now, what do we know? We know, look at your diagram, from the theorems that were given to you before. Line drawn from a center of a circle to a tangent. You've got a tangent, you've got a radius. And what was one of the theorems? That a radius is always perpendicular or 90 degrees to a tangent. A radius is always 90 degrees to a tangent. So we know that this whole angle here must be 90 degrees. Okay, don't worry, yes, we know that what x is going to be, but let's first identify what's given on our diagram. We also have this angle here to be 62 degrees, and we have a tangent and we have a chord, and one of our theorems that we had was angle between tangent and chord is equal to the angle, so angle, that's your chord, PB being your chord, PT being your tangent, or MT being your tangent, angle between tangent and chord, there's it, your 62 degrees, is equal to the angle subtended at the circumference in your alternate segment. So therefore, if that is 62 there, this angle here being 62, obviously angle between tangent and chord is equal to the angle subtended in your alternate segment. So we know, and that is one of our requirements to find out the value of z. And we already know that it's 62. We're going to be structuring it down, we're going to be writing it down on the side in order to achieve our 6 marks by finding the value of x, y, and z. Okay, and obviously we know we've got there's x, there's y, there's z. Can we find x? Can we find x? Yes, we can. This whole angle is 90. So in our justification, you can start with x, you can start with z, you can start with y, in any order, totally up to you. What comes to you first is what you start writing down.